Let's see here a few interesting details about two different types of bone tissue, the compact and the spongy bone. As you already know, when we are reaching the level of body organization that we call the tissue level, obviously it has to be composed of different cells but of the same kind, so they become integrated with each other through their position, through their common function. And of course, we want to see what are the principal differences between compact bone versus spongy bone, and also to say a few words about cells that are actually forming the bone tissue. We will need to quickly share the screen and to take a look at one of the slideshows that I have ready for us. So just give me a second to open it up and to go from this particular slide that we have in front of us. Firstly, I want to just quickly give you a bit of idea that during a human embryo and human fetus and their development, at one point we would start seeing formation of cells that are called the osteogenic cells. They are yet immature, but for us, we say it's a point of no return from the common predecessor, which is called the mesenchyme. Common predecessor means immature embryonic tissue called the mesenchyme. It forms the osteogenic cells, which in the next little while will finally start forming the cells that are called osteoblasts. And then osteoblasts are the first type of cell which is capable of producing bone matrix. A matrix is composed of fibers and a ground substance, and of course later on the matrix will calcify and becoming much harder. Osteoblasts are going to be, so to say, trapped in their own product, and the next stage in their life is that we're converting them from osteoblast, young and metabolically very active cell, into cell which is a little bit more dormant type of cell. It is known as the osteocyte. On the right side of the screen, you have a cell which is also known with a prefix of osteo, but the suffix of clast. These are not cells of bone tissue. They are actually cells that are delivered from class of white blood cells. They are osteoclasts, and their function is to remove old bone, especially bone in which no more living osteocytes are to be found. On this slide, you and I can take a look and see what is the composition of the compact bone tissue. As central part of the diagram, you can see one circular or cylindrical structure which has been pulled out, and that is the osteon. For the osteon, we say that is the base building block of the compact bone. There are multiple osteons that you can see throughout this diagram, and as you can see, all of them are cylindrical in shape. So spaces between adjoining osteons are going to be filled with interstitial lamellae that are incomplete, and they're just serving the need to fill in the space between adjacent osteons. Each osteon is made of multiple layers of calcified matrix, and between those layers you can see somewhat of a darker spaces that are called lacunae, and within lacuna we are to find osteocyte. Another characteristic of compact bone tissue is that within the center of osteon we have a little opening, a canal. That canal is known as the central canal, or also we call it Haversian canal, based on a scientist who was the first one to describe it. And also we are calling sometimes Haversian bone instead of compact bone. So the Haversian canals are running lengthwise of osteons, and they also become mutually connected by another series of channels that are called the Folkman's canals or perforating canals. Obviously that Haversian and Folkman canals have blood vessels that become mutually connected, creating a bit of a network of blood vessels that is required for supply of the bone. Of course, the very surface of the compact bone will have another group of layers or lamellae that are called the outer circumferential lamellae, and ultimately the very surface of a bone, with exception of its articular surfaces, will be covered with another thin and very important layer which contains nerve fibers and dormant osteoblast cells. That membrane is known as the periosteum. On this slide, we can see what spongy bone tissue would look like. Actually, even on a previous slide, which I'm going to bring back to camera just quickly, on the left-hand side of the screen, you could have seen a little bit of this bone being already made by spongy bone tissue. Obviously, the compact bone tissue has to be more peripherally located on the surface of a bone, whereas the spongy bone could actually point more centrally and be part of the ends of the bone, as well as near the central cavity of typical bone, such as what we have on the screen. Composition of spongy bone tissue is made by smaller subunits, and they're known as trabeculae. Trabecula means little pillar, little beam, and as you can see on the left side of the screen, there are multiple trabeculae running practically in any direction they like. But on the cross section through one trabecula, we can see here very similar arrangement of bone matrix, which has been ossified or calcified, creating layers or lamellae. In between adjacent lamellae, there are very minute spaces known as lacunae, containing, of course, osteocytes. And while we're still here on this slide, you can actually see what would be a role of osteoclast. So at one point, it needs to start removing this part of lamella, outermost lamella, because, for example, there is no living osteocytes. They pass after 20, 30, 40 years of life. This lacuna became vacant, this lacuna as well. And of course, the tissue cannot be maintained unless we have living cells. So the osteoclasts will be called upon, and they will start gradually removing the layer or lamella of this bone. But in the meantime, don't worry, this trabeculum is not going to become smaller and smaller until it disappears. You see that on the surface of trabeculum, we have also plenty of osteoblasts. They would start their activity and they would create another new layer on the opposite side, so towards the right side of the screen. While this lamella is actively removed, the new one will be formed, which essentially is the balance that the bone tissue must maintain for whatever amount of bone tissue is removed during any period of time. Essentially, that much of a new bone will have to be laid and deposited, so the net gain, the balance of our activity, is going to be zero.